the Mythbusters.
Hey everybody, how's it going? Here's our water source, the hose. Classical yard hose. Here we are. We got a makeshift connection right here. As you can see, lots of electrical tape, a little bit of PVC, and then we continue on. We travel through. Ooh. Alright, the hose comes through, down up to the speaker. The speaker will play at 24 hertz, shooting the water down into the bucket. The speaker over here is connected to the computer. Sauce it on, show them the 24 hertz. Well, we're going to do various amounts of hertz, but to start things off, we're going to try 24. Here's the little software I downloaded. It is called Tone Generator. The goal of our experiment was to make the water appear as though it was frozen in midair. We researched that the most common frequency used to see the waves in the water was 24 hertz. But unfortunately, that didn't work for us. So we figured out that we needed to synchronize the frames per second of the camera and the frequency of the water. So we found that our camera was 30 frames per second. So in order to see the water on the camera, we had to change the frequency to 30 hertz. So here's our experiment at 30 hertz. 30! And it stopped. It just stopped. So now you can see our frames per second of our camera is 30 frames per second. This is at 30 hertz. Makes sense. You can see 30 hertz, the water was stopped because the hertz and the frames per second matched up perfectly. Next we're going to try going above and below 30 hertz. Yeah, like that, right there. That's money. Okay, 28! As you can see, when the frequency of the water waves goes below 30 hertz, it appears that the water is traveling back into the tube. But when we go above 30 hertz, it looks like the water waves are traveling out of the tube. 32 is going live!
Now it's moving faster.
Yeah, it's moving a little faster down. When you look at the footage of the waves, you can see that the stream of the water is more spread out than it would actually be when the water actually only came out of the tube without being oscillated by the frequency waves. But since we're oscillating the water tube at a frequency, that's why you can see the water waves spread out and get wider as it goes down. It's sort of like when you drop a pebble in a bucket of water, the waves travel outwards and they expand. That's the same thing here, except we're only focusing on like a single stream of water, so it just expands the stream.
It's the same.
What? It's moving that way now.
Yeah.
Now you can see that it's moving down. So in the video we could see the water going up and down, but from human eyes, because of our frames per second is not 30 frames per second, all we saw was the water just expanding as it went downwards, just like a normal stream of water would.
This is what the water looks like with the naked eye.
In the beginning, we hypothesized that if we played 24 hertz of a frequency into the water waves, that we would immediately see like a difference between the waves of the water, and that it would be visible with the naked eye. But as we learned, as we went along, that's not what actually happened. What actually happened was you had to match the frames per second of the camera with the frequency to show the gaps between the waves. And yeah, that's the lowdown.
They put them to the test.
What am I saying? The goal of our experiment was to what? Oh, the goal of our experiment was to make the water appear as though it was stopped in like midair. Oh, that's bad. The goal of our experiment was to make the water appear like it was stopped in midair.